Hello, good morning, good afternoon, good evening to all of you from wherever you might be joining us. I am Tracy Miranda, the Executive Director of the Continuous Delivery Foundation, joining you from a very rainy Ottawa in Canada. So thank you all for being here. Take a moment to let us know where you're joining from. And yeah, I'm super thrilled today to have this conversation around tools and technology choices. And we have some really great folks I'm excited to be talking to, and I'm going to let them introduce themselves. But let's start with Jerop. Thanks for coming, Jerop.
Thank you. So my name is Jerop Kipruto, and I'm a software engineer at Google working on cloud CI/CD, or cloud continuous delivery, specifically working on Tecton. I've worked on projects that enable software engineers to build and deploy cloud-native applications. I am a recent grad. I graduated from MIT with a bachelor's in electrical engineering and computer science. So I'm very new in this field. And I've spoken in previous conferences, including Continuous Delivery Conference. And next week I'll be speaking at the Open Source Summit. So I'm really delighted to be here to share some of the few things I've learned working on Tecton.
Awesome, welcome. And also joining Jerop, we have Owen Adams. Owen, do you want to introduce yourself?
Sure. So I'm Owen. I'm the SRE lead at a company called Intelligent Growth Solutions Limited, which works in the vertical farming space. And yeah, that role kind of sees me looking at things from the local dev environment through to what we're actually running in production and how we get observability onto that and the various choices and challenges which come along with that as well, particularly in a small company which is looking at growth over the next year. So how we build into that.
Awesome. Well, thanks for joining us. Okay. Hi to Melissa and Tracy R. Thanks for letting us know where you're joining from. Okay, so how we're going to approach this. So first we're going to talk in more details and sort of take a deep dive and hear from Owen about the specific case he's dealing with, just understand more kind of the real world issues he's facing. And then from there, we'll kind of take a step back and sort of put this in context for everybody joining on the call and maybe ask ourselves, what does a modern software stack look like? How do we kind of summarize some of these points to turn them into decisions, questions we can ask ourselves for decisions we need to make when choosing tooling and platform choices for 2021, and maybe some of the factors we need to think through. And yeah, we'll be looking to Jerop to share a lot on that. And as ever, folks, please go ahead and ask questions. We've got an ask a question button, or put some comments in the comment box. And yeah, we might even be able to have some of you come and ask them live if you're up for it, and just be part of the discussion. So that's what it's all about, just having real-time conversations and learning from each other. And do feel free to share your own perspectives as we talk about specific things in the stack as we go. Okay, so let's get started. And Owen, first of all, what is vertical farming? Can you start telling us about that?
That is a great question, and it's definitely one I had when I was originally joining IGS. So vertical farming, and particularly the approach we're taking to it, is looking at how resources used for farming at the moment and trying to, one, modernize it for certain crops and also allow it to exist in environments you wouldn't have historically. So for us, it looks more like a factory than a traditional farm. You have multiple towers, you have trays in the towers, and you have lifts which move up and down. And within that, you have a totally controlled environment. So ability to have specific temperature changes between trays, the ability to control the lighting between trays, and the ability to water them on a schedule. So it's a heavy hardware element, and then there's also quite a big software element as well, as far as scheduling things like growing crops in this totally controlled artificial environment. So it's got some interesting advantages to it in that it can be a lot more efficient as far as use of water, use of power, but also it allows us to now look at growing crops in areas where traditionally you wouldn't be able to, be that in the middle of a city or in an extremely hot climate, which couldn't support that traditionally. And that's the idea. It's a very, very high density, totally controlled environment for growing crops in. So I think it's a decent summary. There's probably
Yeah,
something
that sounds amazing.
yeah.
And what sort of things? Is that like strawberries? I'm going to start guessing here.
So early work was largely with leafy greens because they were quite easy to grow. But I believe we've looked into strawberries, looked into chilies, looked into flowers, looked into things like seed potatoes. So it's really, vertical farming as a concept is still quite new, and we're still discovering what we can do with the platform, and our customers are still discovering what they can actually do with the platform. So we haven't really found the limitations yet, which is exciting. But it also means, in addition to the traditional hardware and software, we also actually have a dedicated crop research functionality as well, which is looking into what our customers can potentially grow in this environment.
Perfect. Okay, so I'm imagining just warehouses with chilies all being grown by robots. Cool.
And that's the dream. That's the dream.
So, okay, so tell us what your role is then, and how software comes into this, and what you're trying to do.
Sure. So notionally, my title is Site Reliability Engineering Lead, but because it's a small company, as with any small company, that title is a little bit fuzzy given the day. In addition to the hardware component we've mentioned, we also run a multi-tenant software environment hosted on Azure Cloud, running on Kubernetes, running in Docker, and we have a software department for that. So my job is, and the role of my team is partially empowering the developers to be able to build and run and scale this in production with as little friction as possible. Part of it is making sure we have the correct tooling in place to be able to quite rapidly diagnose problems which do occur, which can be a little bit complicated because some of this isn't necessarily just pure web requests. We've got interactions with hardware, so some of the off-the-shelf tooling doesn't necessarily work there. And then it's also looking into the whole kind of dev release cycle as well. So what does the experience look like from a developer's perspective of writing code against this kind of modern technology stack? What are the pain points there? How can we optimize the experience of working locally versus working on the cloud? So it kind of, although the role isn't primarily about reliability of it in production, the best way we can ensure that is to actually bring production as far as we can left from the developer experience and get that process working and get them familiar with the tools from that point. So that's kind of where the team sits at the moment.
Okay, so when you came into the job, you had an existing tech stack, so it wasn't something you got to build from the ground up, right? Like I think it's a myth. I don't know if there's anyone who has ever had that luxury of starting completely greenfield, but was that the case? You had to contend with something there? Very
much a case, and from prior to IGS, where I used to do more contracting and consulting, it was also the case. I saw quite a lot. Doesn't matter on the size of the company, especially with quite often in an early company, the tooling seems to be largely decided by what the early starts are familiar with. And that's a completely valid way of doing it. You're often trying to deliver value very quickly. So you're picking things which people are familiar with and can iterate on quite quickly. Mm-hmm. And then as you begin to grow, you begin to think more around how does this run in production? How do I integrate these different bits of tooling together? How do I get information out of them? And that's probably around the point I joined. There'd already been an established software function for a period of time, not an extended period of time. It was ramping up for first customer release. And so we had a lot of tooling. We had some really great bits of tools, great bits of technology, but the integration wasn't necessarily there, and the overall insight wasn't necessarily there either. So I joined at that slice, and I think that's as close as you get to really coming at a greenfield. Is there's tooling, but people aren't too married to it at that moment in time.
Yeah.
But yeah.
So do you have a process like by which you kind of assess the stack, or like for anybody who's new to a team or new to a company, like how would they go about saying is this a modern stack, or understanding where there might be dragons?
Yeah, it's actually it is a really tough one, and a lot of it depends on the size of the organization you're going into. Mm-hmm. The place I tend to start with is actually the release process, because that can give me an idea of what types of tooling they have running in different environments, potentially what the kind of handover between environments are. And that release process really for me starts from developer writing first line of code running into production. So I try and get to grips with that and dig into that to see, right, what are our targets as far as platforms go? Are we looking at traditional VMs? Are we looking at on-premise? Are we looking at Kubernetes running somewhere? What's the different artifact storage which is in place there? What languages are in use? Do we have anything like static analysis of code? So it's beginning of that release process really gives me the kind of high level view. And then I use that to start drilling into conversations with not just the engineers, but also the stakeholders or the product owners which are involved to kind of get an understanding of their perspective on the tooling, as well as an understanding of the engineer's perspective on the tooling, because you need to marry those up at some point down the line.
Yeah, no, perfect. And yeah, I really like that, marrying both the engineering side with the kind of commercial or business goals. Okay, so this might be a good time to ask ourselves, like, what does a modern software stack look like in today's age? What are kind of key features? And Jerop, maybe from your experience, how would you characterize some of the features of a modern software stack?
Yeah, I think what Owen said about like from source to production, from a commit to the release happening, and like how that entire journey and path looks like. And I think working on Tekton, some of the things that have stood out for me that are important and we prioritize, among them include fast portability. So in Tekton, we're trying to establish a standard, right? So the standard needs to work across multiple cloud providers and deployment environments. So for example, you can use Tekton to build, test, deploy applications across multiple cloud providers and hybrid environments. And that's very critical in a situation like ours, where we're working on an open source project that's Kubernetes native and needs to work across different systems and environments. And this also enables our users to easily move between different providers or environments based on their requirements. As the business is growing or changing, they can also move along with their tools, and it gives them flexibility to adjust as needed. So that's one thing. I think the second thing I'd mention is security. And this has become a very hot topic recently. And I think it goes beyond detecting vulnerabilities. That's one part. A second part is the software supply chain security. So some of the things that we've been looking at in Tekton is around generating and signing provenance. And we have a project called Tekton Chains that's still very nascent, and that's making progress on this to automate that process for you. So the way Tekton Chains works is that when you install it in your Kubernetes cluster, there'll be a controller that will observe your task plans, and then it will take a snapshot of them when they're completed, sign them, and then store them somewhere. So you'll have proof of what happened, and you can trace it back. A second thing that we're doing around software supply chain security is hermetic execution, where you can specify that some building or some steps in your release process should happen without network access. And this ensures that it's reproducible, it's more secure, and it's one of the best release engineering practices out there. So the third thing I'd mention is extensibility in modern software stack, in the tools that you're choosing. So are you empowering users to build the plugins that they need to get functionality that's not available in the tools directly? So do they have a way to extend the API to get things that they need for their bespoke use cases or their requirements? So in Tekton, the way we are solving this is through something called Tekton custom tasks. So you can write custom tasks and their corresponding controllers that would run on your Kubernetes cluster to provide this extended functionality that's not available in the Tekton Pipelines API. So one controller that I recently wrote is Tekton Pipelines in Pipelines. So we have steps that build into tasks and then pipelines, but we didn't have a form of embedding pipelines in pipelines. And we have use cases we've had from users around needing to be able to embed or specify a set of tasks that should happen within a pipeline. So I was able to write that and experiment with it, and we may consider bringing that to a top level feature. So being able to provide portability, security, and extensibility, I think, are some really key tenets or parts of a modern software stack.
Yeah, portability, security, extensibility. I like that. And so what's the reality on the ground, Owen? Yeah, portability. How's your portability, security, and extensibility?
Depends on how closely you look, would be honest. So actually, this is I want to say actually I agree with everything which was said, particularly the extensibility component. I just wanted to touch on that for a moment because I think it's one of the big shifts we've seen over the last 10, 15 years where it was much more common to be adopting tooling which had limited APIs, where a lot of the data was very closed off. And so the ability to integrate that or to do customizations on that was quite a high barrier. I have written some terrible code to scrape interfaces in the past to try and extract things so we could have it in our own database. And that extensibility is actually really, really important because it gives you that. It gives you the ability to customize it to the business. And when we were talking about briefly matching the business needs earlier, that's so key because it's unlikely that any tool will necessarily provide exactly what you're needing in all the formats you need, but having that extensibility gives you that. As far as portability goes, it's a tough one. It really is a tough one to actually achieve. So I know for our stack, we've adopted Kubernetes, we're using containers for a large portion of what we're doing. And about 95% of our stack is actually fairly portable. But I'm also very aware we have this 5%, which is a Azure service bus, which doesn't have any local emulator, doesn't really have a way to move. It is technically AMP-Q1 compliant, but we're not really using that. And so we do have this little rot right in the middle. And I think I see that quite a lot is there's often a balancing act between making use of cloud native functionality and making use of a specific provider's functionality versus using something which is more of an open standard. And you have to evaluate that on a case-by-case basis. Sometimes the engineering effort involved in rolling your own, say for the service bus and running our own and managing that was higher than we could spend at the time for just adopting what Azure was providing. But we also know if we did need to move away from that in the future, we'd have the ability to do that relatively easily through good code design. Things like being able to make use of dependency injection in the future to swap out what we're currently doing with a different service bus is there. And I think that's one of the hard things actually when you're making those technology choices is those trade-offs. In an ideal world, every single part of the stack would be portable. Every single part would have a full security compliance and also supply chain, and every bit would be checked and every single bit of it would be extensible. Realistically, you can get most of the way there, but you do have to make those trade-offs quite often around, okay, where can I spend time right now? We have a limited number of developers. We have certain features which need to be delivered. How do we make this? The big thing, which I think is important though, which sometimes gets missed, is making an informed decision on that is really important, not just kind of blindly walking into it, but making use of things potentially like architectural decision records to capture the context on why a certain tool was chosen with the knowledge that, yes, it wasn't as portable, but this is why. So people can look back at it a year or two down the line and go, okay, we made this decision, now our circumstances has changed. How do we reevaluate that?
So that's an interesting one. So you called it what, architectural decision records. So capturing the thinking at the time.
Yeah, so specifically less about necessarily capturing the exact architecture, whether that's useful, but that is very subject to change, but more around capturing the context on why a decision was made, what were the pros and cons which were considered, what was looked at as alternatives, and why was that decision made? Because I found that context quite often gets lost and quite often gets forgotten, especially if people come and go or if it's been a period of time. So, and I know myself, I've definitely come into places and gone, why on earth did they make that choice? And sometimes I found out it was actually a choice I made, but I forgot about. But
can relate.
Yes. Why on earth did they make that choice? And being able to capture the context on that choice actually provides everyone down the line a greater understanding of what the trade-offs were and if any of those trade-offs are still valid.
And how much, when people are making their choices, how much is dictated by like being locked into an ecosystem, either by programming language or choice of cloud or things like that? Like, what's been your experience with how much freedom you have to choose from all the available choices?
Sometimes not much. So it does depends on the organization. So if you're working in more regulated sectors in particular, your number of options which you have, or if you're working in government where there's a specific procurement process you have to go through, your ability to quite rapidly change to something new or adopt something new is limited. Even without that though, there is a challenge in not wanting to bring in too many different providers, too many different sets of tooling. which is why making smart choices when you can is quite important. So if you've got a relatively small team, each new provider, even if it's just using Azure and say Google Cloud, being able to bring both of them to bear requires cognitive load around management. That it requires simple things like setting up users, setting up security. So even when you're in an environment which does have that flexibility, and a lot of startups do, you still sometimes have to limit yourself and kind of have to make a decision of, okay, we have these core bits of platform. So for us, I would say we're on Azure, we use Kubernetes. There probably are two, and we are primarily a .NET shop with a limited amount of Python. So there are main constraints. While we would be able to move out of Azure for something on Google Cloud if there was a compelling reason to, part of the kind of thought process on that would be, okay, what is the operational overhead of doing this? What is the cognitive load on developers? How can we abstract it away in such a way? And do we have the time to create those abstractions in order to do that? So you will generally go for your kind of preferred platform and tooling in the first case. And then if you can't find it, potentially look elsewhere. But that's only if you have that flexibility. As I said, there's plenty of places where you don't have that option.
Yeah. And I think trying to bring in that right level of abstraction is one of those problems that the Tecton project is trying to solve. And like, Jerop, for you, what are things that should be considered when you're making your tooling and platform choices?
Yeah, just to continue on what you're saying about having different levels of abstraction. So like we have Tecton, which provides or gives you most of the control that you would need while abstracting away the Kubernetes implementation detail. But you can have something like Jenkins X that uses Tecton as its execution engine, which provides a different level of abstraction away, and even things like IBM Cloud or OpenShift. So having a standard but then having tools that build on top of it and interoperate with it then gives people different levels of control or flexibility around this. So beyond portability, security, and extensibility that we just discussed earlier, one of the other things that I would consider when making tooling and platform choices would be around interoperability and observability. So around interoperability, like Owen was saying, one size does not fit all. So like, do the tools that you have in your stack or interoperate with other tools because in many cases you find that you need a combination of tools to meet your requirements or to solve your use cases. So you need to consider how these tools work with other tools. So in our case with Tecton, we care a lot about interoperability. So it interoperates with Jenkins X, Scaffold, Knative, even GitHub Actions, Argo CD, and many other continuous delivery tools. So you can take what you need from each of all these tools to fit your specific use cases and requirements in your organization. And the second part is observability. So it's very critical to be able to capture metrics and observe events, trace logs, etc., to get insights into your tooling and processes. So for example, as you're incorporating some of the continuous delivery practices or processes, you can get measurements into, like, for example, the 4 key software delivery performance metrics from the Accelerate book, such as like lead time, deployment frequency, mean time to change, things like that. And being able to get some of these insights then can help the organization be able to influence future decisions or choices and adjustments that are needed to be able to deliver your software safely and quickly to your users. So beyond portability, security, extensibility, the 2 other things I want to bring into the conversation is around interoperability and observability.
Yeah, no, I think those are great points. Love the 4 key metrics as well. Nice shout out to those.
Yeah.
But let's go to observability, because I think, Owen, you touched on that, and Jerop raised some good points about observability. And it's not something that was even like a term a few years ago, but where does that feature in your level of concern, and how are you tackling the whole observability part of your stack?
It's actually been a really big focus. It's probably been a big focus for about 6 months now, and we've finally landed on something which we're happy with. It's hard. Actually, I'm just going to put out observability, and doing it well is really hard, particularly when you start talking about quite modern platforms and modern software stacks where you have a lot of dynamic services, you have a lot of automation, such as on Kubernetes, making use of operators and having that dynamically scaling in the background. And when you throw in a hardware component as well, It does get challenging, but there's been some great strides on it in the last few years. Particularly, Prometheus, as in some form or another, has kind of become a standard as far as how things are exposing metrics in Kubernetes. You've got eBPF, which I'm incredibly excited about, which is like kernel level tracing in a very low impact way, which is built into the Linux kernel. I highly recommend people look into it if they haven't. I think it's going to be a big thing in the next 5 years for observability. And finally, the actual code level observability. And this is where we have been approaching this recently. So generally speaking, we're talking about tracing events, metrics, and logs, and some of it, OpenTelemetry is a good example of which covers some of that. And while that's how I would tend to break down language if I'm talking in an audience such as this, when I'm actually talking to engineers, a lot of the time, particularly the software engineers, those boundaries aren't as clear cut. Infrastructure metrics they have as a model. So there's stuff about infrastructure like SQL, CPU usage, and there's logs from the application, and maybe we get traces. And so one of the things I found is you have to do a big education piece, first of all, around what modern observability can look like. And by that, I mean the ability to actually follow a journey through the application. So you want to, in an ideal world, be able to follow a user from logging in, say, for your front-end service, maybe that's implemented as a BFF, all the way through to their interactions with any services in the back end. For us, we want to be able to follow our command scheduler. When that ticks over and it goes to run a command, we ideally want to be able to trace that at the code level throughout the different microservices, ideally on the network level, but also look into what kind of impact that's having on the infrastructure as well. So are we doing something which is causing excess DB load, and how does that map to the path in the code which is being taken? And that's a really powerful thing to achieve if you can get there, particularly if you can put that level of observability into your developers' hands from day one, from local. So if it's something which isn't thought about as an afterthought, but it's something which is built in. So we've actually ended up using New Relic for this. We were originally looking at running an open source version, but small team, we decided that actually, given the size of our team and the complexity of this, looking at SaaS options is the right way to go. And that's one of those kind of choices we had to make. Part of the reason for that was it's very extensible and quite interoperable with what we've already got. But the biggest deciding factor was they have really good .NET libraries, and we're a .NET shop. So being able to actually
language choice again coming in.
Yeah. So being able to trace the code in a fairly native way from a .NET perspective, initially just dropping it into the agent into the containers, and then working with developers to actually add that in a way they were familiar with. Plus the integrations, we're getting to that point where we've got that kind of full stack observability, but so much of it is a language choice. If New Relic hadn't had strong support for .NET, we would have had to have looked elsewhere. If we had a larger team, we might have looked at adopting OpenTelemetry and something along the lines of Prometheus so that we could customize it more. So we had to kind of really narrow in those requirements, and that took a lot of education, a lot of training people, because initially the dialogue we were having was the same set of vocabulary, but two very different perspectives on it. So there was an initial stage which was teaching people about what we were looking for and what we meant when we talked about traces and events, and what we meant when we talked about that level of information, so that we could then have the conversation about requirements before we actually looked at implementing something.
So just getting everybody on the same page and having a common language, so you're not talking across purposes.
Very much so. And that can be, it's a really powerful thing which we're seeing in the industry around the line between what was traditionally a software engineer concern and an infrastructure concern, because it is now becoming a software engineer concern. You have software engineers who potentially specialize in the infrastructure side. You do still have some sysadmin functionality, and you have your software engineers who are focused on the feature development. And while that's incredibly powerful, everyone is coming with their own vocabulary from their own specializations. So we are seeing a lot of friction, which is often just caused by people not sharing the same vocabulary for various terms.
Yeah.
I'd like to mention what you said about stepping through and walking through the path is quite recall. And one exciting feature that we just introduced to Tecton that I probably should share here is debug mode. So other features are table stakes, but I feel like that is one differentiator in Tekton where like you can actually debug your continuous delivery pipelines. So in a task, you can specify like at this position, I want you to stop, and then you can step through it and see how that's working. Just want to point out that like that's also one thing that going beyond being able to step through within your application itself, but also being able to step through within your pipeline is something that we are now enabling or making progress towards. I think it's actually already released, but yeah, hopefully we'll also be included in our V1 release coming later next year.
So actually there's a really interesting bit there, which I think a lot of people ignore, and it's something which we're not doing yet, but we're working towards, is actually treating your pipelines as a first-class system, treating your build system as a first-class system, and being able to have that debug mode like with Tekton, or instrument your pipelines in other ways, because I've seen a lot of time lost trying to debug pipelines, but also it's such a critical part of your actual software delivery. Bugs in that pipeline, missing steps in that pipeline can cause production level issues if things are getting through your process.
Yeah.
So being able to instrument that's really, really important, and also being able to match back deployments to application code and application versions. So I know, tools like Altelius are looking at that from the overall release process. How do you actually map those kind of services to a version, to a set of changes? And I think that's something which we're seeing becoming quite really important with larger modern software stacks.
And do you mind talking about, you talked about the size of the team. Is that something you can give us an indication, just so we can put things in context?
Yeah, at the moment it's 3 engineers, or 2, actually. I think we've just recently lost a junior. So that is compared to, I think, around 20 software developers at the moment. So there's a bit of an imbalance there.
Yep.
Previously, I've worked on larger teams, but what I found quite interesting with the team size is you can achieve a lot with a team around 5 people. Enough people to kind of deal with some of the operational stuff and also do some of the development on upcoming work. When you're at very small, you really need to look at more SaaS providers. When you get to about 5, 6, you kind of have a bit more bandwidth a lot of the time to deal with operational and actually looking forward. As it grows beyond that, you really need to then start adopting like proper sprint teams or scrum teams or whatever's working internally, even for the more operationally minded side of things, and trying to align that with what's going on with development. But yeah, quite small right now compared to the number of developers.
Yeah, no, I like that kind of progression of how the team grows and what you can do more with. And I guess that kind of leads into, I have to ask, have you looked into Tekton? Is that something, like, we know adopting technology is not easy. What are the factors that you kind of consider?
So I personally am a big fan of Tekton.
Thank you.
But one of the things I'm excited about with Tekton as well is the potential for Tekton to be a platform for other tooling. So we're looking at, there's Puppet Relay out there, which is built on top of Tekton. If I remember correctly, you've got Jenkins X, which is built on top of Tekton. It's a really interesting platform as far as a set of primitives which can then be built on top. For us, we are actually, one of the biggest pains I have at the moment is with our release tooling. So we're using Azure DevOps, which comes from quite a traditional background. I think it used to be a team foundation server, something along those lines. Only recently, in the last few years, got YAML support for pipelines. Prior to that, it was all UI-based, which is another big technology choice you have to make, particularly nowadays, is we want as much as code as possible. We want as much of every step of what we're doing to be able to go through the same process of code review and analysis and testing against it. So one of the things we are considering when we do move away is Tekton. But the thing which is probably going to prevent us from doing it is relatively small team, relatively small organization. Tekton, incredible piece of work, isn't necessarily the most user-friendly for us at this moment in time with where our skill sets are at. It's a little bit more complicated to set up. The UIs around it, CLI side of it is great, but actually the UI experience, the dashboard experience by stock, is not as clear for particularly some of the software engineers who don't necessarily have as much of a background in using containers essentially as ways to compose pipelines and getting that feedback. But it is something we will evaluate and this is one of the things which will probably be next year. we'll go through the process, keep it relatively lightweight, but do an initial architectural decision record of some kind on what we've considered and what the pros and cons are, and try and keep that process lightweight, but enough to kind of say, yeah, we have looked at this and this is why we didn't at this moment in time, but maybe review it later down the line. But yeah, I'm personally very excited by Tecton, but I think there's still a challenge there when it comes to delivering it to an organization which is, one, quite small, and two, is used to a lot more of the kind of high level abstractions on top of their build pipelines as far as the interface goes and as far as the management of it goes.
Yeah, no, I love that you can give the direct feedback straight from the user. Go ahead, Joe.
I would say feedback is a gift, and I really appreciate you giving us that. Those are sentiments that we've had before, and we're making progress towards them. So there's a lot of effort in the dashboard to get it up to speed with like our user expectations, and also without getting started documentation and getting new people ramped up on the project. As I mentioned earlier, we're working towards our V1 release, hopefully for early next year. And definitely, like, we'll come through our docs and make sure that we have that full experience provided to our users to get people up to speed quickly. But I really appreciate you sharing your experiences using Tecton so far. Thank you.
Awesome. Okay, and I think this takes us to a pretty key topic, like a big space. Like we've touched on all these things like interoperability and observability and security and choice of tools, and then you have to pull this all together into like a seamless developer experience and kind of bridge that gap between people doing their local development on their laptops and stuff running in the cloud. How do you go about doing that? How are you thinking about that developer experience?
A lot of communication. Like, and this is one of the things in my ideal world, divorced from reality, it would be a case of we'll work with developers, we'll get some really nice defined requirements and acceptance criteria, we'll turn them into tickets, and we'll do work. That'd be great.
Sounds good.
Yeah. Similar to the observability piece, though, it doesn't really work out that way, I've found, particularly when we're talking about things like Kubernetes, when we're talking about modern cloud practices and infrastructure as code, when we're talking about potentially tooling like Tecton. A lot of the people who I speak to from a software engineering perspective don't necessarily know what they're missing. They know that there's frustrations with the local development environment, but quite often it's something which has become accepted. There's workarounds in place. There's, cumbersome processes which they're trying to bypass, or they won't be aware of the potential there. So just starting from hey, could you tell me what's wrong, doesn't work, because a lot of the time it's become so ingrained that we're not even necessarily thinking about it on a day-to-day basis. So there's two key areas which I think are really important, well, three key areas. One, building that relationship, trying to treat everyone in that engineering space as a software engineer, trying to dog food it, but also trying to build relationships with people so they feel comfortable talking to you about stuff. Not being a gatekeeper, not being a kind of, a boogeyman where people don't want to go to for help, and actually trying to support people, even if that, for me, is not necessarily a core part of the job, but actually making that time to have a chat with people, to see what they're doing, to let them approach me and my team about things which are definitely not in our wheelhouse. But at this point in their journey, it's actually really critical they can do that, because they will approach us about things which can go, oh, we can improve that. We can create a ticket on the backlog and dig into that. So we kind of need that level of information right now. One of the other big bits which I touched on there was, where possible, dog fooding what's happening. So for us, we make sure that although we're not working on the features which are going towards the customer, we make sure that any infrastructure as code, any pipelines, any custom tooling we're writing goes through the same process. It all has to go through the same kind of environment release process. It has to go through the same static analysis. So we're experiencing it as much as we can. And the final big thing is, I found pairing with people is really powerful. So if we know that there's a feature which is going to be coming up, which is going to, like we had one recently about introducing a Kubernetes operator to help scale up some of our environment. So we were writing the operator code because we were really familiar with that. The feature team were working on the .NET code, and we also had some new infrastructure we had to bring as part of this. So actually pairing on that really closely exposed so much pain, such as simple one, how do I write and test against a Kubernetes API locally? Well, there's so many options you can use for doing that, from mocks of it all the way through to running a full Kubernetes environment locally. And so actually being able to capture that information has been the biggest part. Now that we've kind of beginning to get that information, we've got that very close relationship with the software engineers which we work with, we can now collaborate on improving it. So I know one of the senior software engineers is really looking at using Scaffold and Kind at the moment to improve the local developer experience, which is something we'd experimented with previously, but there wasn't enough familiarity in the wider team and to make it work. So he's now taking that on board as something he's working on, and that's great because we can collaborate on that, and it's not necessarily us owning that whole process and then trying to throw it over the wall or trying to teach them. It's actually something we can do in parallel. And I think that's one of the biggest things when you actually do start improving the local dev experiences, finding developers who can, or finding teams who can be kind of evangelists for what's coming in and will really adopt it and really will help drive it in the wider community as well by being involved in it and showing it to people. So
yeah, that's great. I like that pairing, dogfooding, and building relationships being key. It makes so much sense.
Yeah, actually, I wanted also to point out that dogfooding has been very helpful for us in Tekton ourselves because we've been able to identify needs by being users ourselves of Tekton. So, for example, Tekton Pipelines is released using Tekton Pipelines and other Tekton projects as well. But even the new project like Tekton Chains, which is the one that signs releases, for example, like Tekton Chains signs its own releases using Tekton Chains. So like having that kind of dogfooding and getting feedback back from using your own software has been really helpful in our use case as a user of Tekton.
Yeah, so you can talk about it from that point of developing it. And what about, maybe I can ask you about pairing. Do you tend to do a lot of pairing in your development?
A few times, like if they're like a new contributor who needs guidance on something, they're not familiar with a particular part of the stack, and therefore can reach out to one of us owners of any of the Tekton projects to get guidance or at least some help to like get a jumping point of where they can continue to make their contributions. So many of the times that I've seen pairing work, it's mostly for new contributors who would like to get some familiarity into the code base. And it has been really helpful to be able to build those kinds of relationships and establish mentorship and get more people giving back to Tekton while they use it as well.
Oh, that's awesome. And yeah, everybody, I'm just going to do a quick reminder. We do have time for questions. So if you have some questions, either pop them in the comments or in the Ask a Question box. And then I won't feel like I'm hogging all the time. But in the meantime, I do have lots of questions still to go. But yeah, Owen, maybe going back to kind of that local dev and connecting that experience up. And you mentioned the word mocking. And I want to know more about that. And is that something you do? Is that something people do in general? It sounds like a lot of extra work for some benefit. I don't know. Where are you on kind of mocking stuff?
So it's not something we do to a great deal at the moment. Although I have seen success with it in other organisations, and I know we've had chats with the end user council around other places which are using it to great success. What we have been exploring at the moment, and this has come from being driven by one of our senior software engineers who's also kind of taking ownership of more of a software architecture, is leveraging .NET, some .NET features around doing API testing. So spinning up a kind of shim of the API in order to do testing against. And I think that will be very powerful for what we're looking to do at this moment in time. But the actual testing piece gets really interesting because, standard mocking can be very powerful. You've also then got contract testing, which some people are looking to utilize, particularly with microservices for creating those contracts between them and being able to have those kind of independent releases. But it is a time sink, and I think it's a very important time sink and a very valuable one. But trying to understand where to invest testing effort, I think, can be quite difficult because you do run the risk of having a large amount of very time-consuming tests, which don't necessarily actually provide you much insight into what's happening in the code. So having a strong QA functionality can be useful, and I don't necessarily mean that as a separate team, but people who are within feature teams who have that kind of mindset, who can help around how do we actually think about testing the problem, particularly something we face. So instead of mocking for our PLCs, we actually end up writing a whole simulator for it, because we have this big bit of hardware which we have to interact with, which is expensive. So we've written an internal simulator for that. But I would say for us in particular at this moment in time, our testing strategy is still very much in flux. So I'm expecting over the next year, we see more use of these kind of back-end API tests, which is being worked on by the feature teams at the moment. And we see more utilization of potentially something like contract tests, or being able to spin up small slices of the overall stack, because they're meant to be decoupled. So being able to bring that up for slightly more in-depth testing locally. But that's one of the big things, is for me, a successful testing strategy has to enable it to be done locally. You might run a more intensive version of that as part of the release process. You might, instead of using mocks or simulators, you might use actual services and physical hardware during that process. But ideally, you want as much of that to be able to run locally, so that developers can have, or software engineers can have a sense of ownership of it. They can work on the test while they're working on the code. They can work with, if they've got QA functionality, on having the higher level tests live alongside that, and they can run through it locally when there is an issue. This becomes particularly important from my view for if you run into problems, things like being able to use git bisect to be able to run through a set of commits and be able to run a test suite against it locally can become really powerful as a way to kind of debug where something was introduced.
Great. Okay, and I'm gonna maybe switch tack a bit and just tackle the big aspect of technology debt or legacy. And it feels like these days things are moving so fast. Like, people are building amazing platforms like Tekton, and even if you stand still, you end up falling behind because everything is changing. Like, it feels like everybody has to get really good at constantly refreshing their platforms and improving that. And how do you go about, like, do you have a strategy for reviewing those architectural decisions, looking at what's out there in, available in open source or in SaaS providers, and just updating your stack? Or like when Drop's got Tekton 1.0 out, is it time to adopt it? Like, how do you even start tackling that?
There's no good way of doing it. I think it's a short version.
All the truth bombs today.
Yeah, I think you can come up with a lot of strategies for it, but it depends on what's driving it. Ideally, and what we've kind of got at IGS, which I think is going to be successful for a time, at least we'll see if it is still successful if we get larger, is people being very open when there's problems. So we'll review technology not necessarily on, we've made some decision we want to change, but we are building a kind of a list of known pain points, of known snags. We have tickets in the backlog for, I think we changed the name, but essentially engineering pain points would be the short version of it. And we have regular architectural reviews where we go through things like the ADRs, and if ones need to be reviewed or need to be superseded, we can mark that in a very lightweight way. These are all just very simple text documents. More generally, though, if you're in that position, it can be really powerful, because you're able to drive, okay, we know we've got these pain points. We know it's kind of having this kind of impact on us. Let's start doing a review and see what else is out there. And that's the best position, I think, to be in, is just continually look at what your pain is. If you can, if it's open source, work with the open source community, either contribute to it or raise it as an issue, try and work with them to extend it. If it's an enterprise provider and you're in a position, you can maybe negotiate with them. And that's the best place to be. The reality is I don't always see that for perfectly valid reasons, particularly if you're working within an organization which is not a technology company. So it has a large technology component, but what you'll often see is things have gone years without being reviewed. things have got quite large, there is sometimes maybe a lack of direction or maybe a lack of insight into what's happening. And in those situations, you're often in a position where you have to fight for review. And that tends to be more batched. So, every 5 years or so, you'll see some kind of big digital transformation and some kind of refresh. And that's not necessarily a terrible thing. When organizations get to a certain size, particularly non-technology focused ones, that's how they do it, that's how they budget for it, and that's how they plan around it. But in that situation, it's more important to, coming into that, know what you want to address and be able to poll people and get an idea of, okay, what's our pain points across the board? We're going to be doing a lot of changes at once, maybe getting contractors to help. How do we at that point put in a vision so that we're going to be content and happy for the next few years and we can make small incremental improvements to it? So I'm quite lucky that that's not where I'm at, because that's always challenging to deal with. But both of them have their kind of pain points and also their advantages as well.
Awesome. And I think, just from our perspective as the Continuous Delivery Foundation, I think we see that as our role to just try and get the information out, have people like yourself come along and share their stories. So there's opportunities for people to pick up how people are approaching it, have folks like Jerop come and talk about all the great things happening in Tecton. So at least we build up that awareness of where things are headed and what exists out there. So this has been a really great discussion, and thanks everybody for joining us. We do have a lot of different communities which you can stay part of. We have the End User Council that discusses specific stories. We've got the Tecton communities and also efforts around interoperability with the special interest group on interoperability. So just to wrap up, I want to ask each of you, Owen and Jerop, if there's one thing people have to take away, what would be kind of your key takeaway for everybody as they kind of tackle their tools and technology choices? Who wants to go first?
Owen, you can go first.
Okay. I think the biggest thing I say to take away from it is don't forget about the local development experience, which seems like a really narrow thing to say, but it has so many manifestations around it, around developer retention, around motivation, around your actual ability to validate things in production. So as people are moving to cloud and increasingly adopting cloud workflows, remember to think about that local experience and remember to kind of make that a first-class citizen of whatever you're looking at, to ensure that you are empowering your developers in that way and you're not kind of keeping them completely isolated from what's happening further down the line.
Great, I love it. Make your local development a first-class citizen. Over to you, Jerop.
Yeah, I think my key takeaway would be one size fits all is not practical. So considering your use cases and requirements to find tools that interoperate to solve your use cases and the requirements that you have in your organization. So in this case, what is your environment? What are the tools that you need? And how do they all work together to solve for your customers based on their needs? So one size fits all is not practical, and interoperability is quite key in the modern technology choices that you make.
Yeah, no, I love it. Big fan of interoperability, and always happy to fly that flag and push for more of that in the industry. Okay, great. So thank you very, very much for being here and for sharing those perspectives. Which I think is great, and for giving each other feedback, which I always think is amazing. And thanks for everybody who joined us. I want to do a quick shout out to our next event. So we are loving using the Crowdcast platform and just being able to have these open free-form discussions. The next one we have for you is coming up in October. And that will be on the State of DevOps report that comes from Dora and Google. So that just dropped yesterday. If you haven't had a chance to check it out, I highly recommend you go and have a look at that report. It's got lots of great insights for your kind of software journey. And then we will have Dave Stanky and a panel to talk about the report and also answer your questions and dig into some of the insights shared in that report. So we've got the link there, so go ahead and register to join us for that. And before that, for many of us who will be taking part in KubeCon. So Continuous Delivery Foundation will be attending KubeCon from October 11th. We've both got options for those who can be in person, but also virtual, so nobody's left out. So yeah, follow us on Twitter to get more updates on that, and we'll have a whole schedule of different events and sessions that you can come along, not just to learn, but just to meet some of the community members and yeah, say hi and get to know people. So I hope you'll join us at those events. Thanks again, everybody, and thank you so much, Jerop and Owen.
Thank you, Tracy.
Thank you.